The unquestioning acceptance and refusal to envision alternative explanations leads to a festering of inconsistencies that pile up until the tipping point is reached, said Jeremy Rifkin in the Zero Marginal Cost Society. Such is the case with Agile and CMMI, two paradigms that appear to be diametrically opposite, or are they perhaps coexistent, or even mutually reinforcing? To what extent is Agile or CMMI at the tipping point, and why? On the LinkedIn blogs, the advocates of Agile or CMMI so vigorously reject the alternative explanations of the other camp that sensible discussion of coexistence of the methods seems beyond the tipping point. Until now, a new way of thinking put forth by Ivers Jacobson in the Software Engineering Methods and Technology, SEMAT, and the Essence Kernel may supply the key to this puzzle. The purpose in preparing this YouTube is to demonstrate in practice the way of thinking of SEMAT and its Essence Kernel and its utility in framing the harmonization issues between two disparate approaches, the Agile method and the CMMI framework. Underlying the opportunity value proposition, expanding and accelerating the dissemination and adoption of SEMAT and its Essence Kernel will be accomplished by systematically demonstrating its application to the audience and user base of the leading frameworks and methods, thereby engaging and involving these audiences in SEMAT and its Essence Kernel, its way of thinking, and its way of working, and yielding new converts. The largest audiences among the leading frameworks and methods are Agile and the CMMI. And so we start there with the strategy for harmonizing Agile and CMMI tensions. The issue is whether Agile and CMMI harmonization is a done deal, or whether Agile and CMMI harmonization is a work in progress, with the heavy lifting yet to be committed to and undertaken. Let's begin. The CMMI is a process maturity framework, and Agile is a software development method. Watts Humphrey defined software process as the set of tools, methods, and practices used to produce a software product, where the quality of the software process largely determines the quality of the software products that result. With Agile, and to Agile's credit, the Agile developer and the customer are in the same silo, inwardly and intently focusing on the essential needs of the project at hand, no more, no less. Everyone and everything else is outside the silo. This is in contrast with the CMMI, with its top-down, global, compliance-driven, organizationally focused culture. Properly aligned and harmonized with the CMMI process maturity framework, an Agile implementation might be considered an instance of CMMI implementation. However, the majority of Agile implementations are non-compliant with the CMMI, even at its lowest process maturity level, Level 2. The Capability Maturity Model, CMM, for software paved the way for software process improvement for software development. The Capability Maturity Model integration then extended the space to include systems and systems engineering process improvement for acquisition, development, and sustainment. With its capitalistic vertically integrated tilt, the Capability Maturity Model integration, CMMI, has been selected for adoption worldwide by government, military, and commercial organizations as the standard for process improvement. The CMMI is a framework of best practices that focus on assuring product quality through process performance. From the outset, the CMM eschewed practice-based methods in favor of an overarching framework. Beginning with the innovators and early adopters, of the CMM in the late 1980s and proceeding with the early majority in the 1990s. The CMMI is now left with ferreting out and harvesting the late majority and laggards, while its infrastructure of lead assessors, like members of a guild, struggles to sustain the market and their place in it by continuously refining and tinkering with the mechanics of compliance underlying CMMI assessments, while ignoring the more essential underlying practice-based methods of software engineering, software product engineering, and software project management. Not so with upstart Agile and its free market, laterally integrated approach as it continues its disruptive intrusion into the space, like lava from a volcano. More popular with programmers themselves, Agile offers an actionable method for practitioners, not simply a framework for middle managers. More than that, Agile empowers and assigns programmers the decision-making for their way of working, previously reserved for middle managers under the CMMI regime. Consequently, Agile values freedom of choice and delivers innovation while rejecting and disparaging notions of compliance. In short, Agile connects with programmers who do the work and customers who use the work, while CMMI connects with middle managers who oversee the work. Still, not without value, the CMMI has its advocates and deserves to have more. Despite the abandonment of the U.S. Department of Defense, the original funding source and sponsor of the CMM and CMMI. Without committed capitalistic sponsors, the CMMI is like a ship at sea, with a valuable cargo that will never reach port until its opportunity value proposition is resurrected or renovated. Such is the CMMI quandary, balanced precariously between the state of being undervalued and the state of yet to be fully valued. Beyond these struggles from the trenches, some are intent on extending the range of value of the CMMI and committed to renovating the CMMI opportunity value proposition with a new way of thinking. It is now time to leapfrog beyond a dwindling market, pesky Agile disruptions, and an overly compliant lead assessor infrastructure to the new way of thinking put forth by Ivers Jacobson in the Software Engineering Methods and Technology, and the Essence Kernel as the actionable and practical means to unlock the value of the CMMI in the large and strike the right balance between practice-based method and overarching framework. Few organizations are finding that their existing governance strategy works well with Agile teams. Furthermore, the CMMI does little to help empower development teams to solve the common challenges faced each day on the job. An Agile implementation cannot be CMMI compliant by accident. Instead, an Agile organization needs to make an explicit commitment of intent and resources to CMMI implementation, must exhibit process-based confirmation through people, must demonstrate process execution-based verification, and must demonstrate outcome-based validation through measured results. This is a tall order, and the Agile community falls short, beginning with its lack of commitment. Similarly, the CMMI framework cannot encompass, adopt, or embed Agile by accident. Instead, the CMMI framework needs to make an explicit accommodation to Agile orientation and its inward-looking, bottom-up, local, need-driven, team-focused culture, and its sensitivity and adversity to management interference. In addition, the Agile community needs to make an explicit accommodation to CMMI and its top-down, global reach, compliance-driven, organizationally focused culture. All this, too, is a tall order, and its likelihood depends on leadership, so far not present. Beyond just religious-like zealotry, perhaps there needs to be a litmus test for evaluating Agile and CMMI. For example, which approach deals with the challenges of cybersecurity more effectively and why? Also, which approach deals with the challenges of austerity? Rather than simply insist that cybersecurity is paradigm neutral with respect to Agile and CMMI, perhaps the answer could be framed around the expertise needed to meet the challenge of cybersecurity, including build security in practices and behaviors such as software assurance, trustworthiness, and rigor. How do Agile and CMMI stack up in addressing the challenge of austerity? Agile, with its inward-looking, bottom-up, local, need-driven, team-focused culture, tilts towards austerity. How do they stack up on trustworthiness and software assurance? Whether companies or governments, the current economic climate is one of austerity. This austerity and affordability challenge has the effect of tying our hands just when the starter's gun signals the start of the race for the 21st century. In accordance with the austerity of the times, the immediate goal of practical next-generation software engineering is to drive systems and software engineering to do more with less, fast, using smart and trusted technologies. Clearly, austerity is Agile's long suit. Software assurance only has meaning in the context of trustworthiness, that is, worthy of being trusted to fulfill the critical requirements needed for a particular software component, system, or system of systems. Software assurance demands two capabilities associated with trustworthiness: the capability to produce trustworthy software products and the capability to verify that software products are trustworthy. Each depends on engineering and technology rigorously applied. The kernel of the layered defense approach to software assurance is build security in and structured programming with its rigorous and provably correct use of 0 and 1 predicate prime programs, along with the proper programs composed of multiple prime programs limited to single entry and single exit. Prototyped in 1988 and now retired, the original CMM focused on software processes. Introduced in 2000, the CMMI focused on software development and was expanded to include systems engineering, product acquisition, integrated team, and requirements development. The CMMI is now organized into 3 constellations and has become the basis for assuring the organization's capability to perform software development, acquisition, and service. The current CMMI is labeled version 1.3 and was released December 2010. Due to its origins, the CMMI lacks an explicit correlation to business alignment and strategic planning, sources of essential value to the enterprise. In addition, the CMMI may operate best in a closed system with top-down command and control decision-making. In open organization environments with more diverse bottom-up consensus-based decision-making, other choices may be preferred. With pressure mounting on the value of the CMMI, the benefits of Agile and iterative development methods known since the 1970s, and the widespread adoption of Six Sigma, the source and range of value of the CMMI are becoming questioned and tested. Even Watts Humphrey expressed concern. Asked about the direction the CMMI was headed, Watts conceded that the CMMI had a problem with performance for high-maturity organizations, and specifically cited the use of process performance baselines and models by lead assessors. He made a careful distinction between procedural, the what, and operational, the how, in the way of processes. Whereas the procedural process depends on a bureaucracy to enforce it, the operational process depends on coaching, a self-managing, trusted workforce, to apply its methods. In accordance with the need to foster innovation, the bureaucratic top-down appraisal-driven compliance may be giving way to more diverse bottom-up self-directing team empowerment and self-determination. Just as the CMMI focuses on the what in assuring a product quality through process performance, Agile deals with how to build software through well-defined methods that place an emphasis on increasing customer satisfaction. Similarly, Six Sigma further supplies the how with an emphasis on the systematic use of artifact templates, measurement, and control graphics in data-driven decision-making and the reduction of waste. Carnegie Mellon University Software Engineering Process Maturity Framework is composed of 5 levels. The initial stage is characterized by no orderly process and an absence of expectation. The second level has defined processes for managing software cost, schedule, and change, all necessary to sustain the commitment process on the project. Level 3 has defined processes for technology, such as systematic design, and the technology transition mechanisms that assist its application throughout the organization, such as software engineering process groups. Level 4 has initiated process and product measurements. Level 5 utilizes the process measurements systematically to continuously improve the process and its products. The value of the CMMI can be viewed comprehensively in a systems perspective and is ultimately determined by the increasing value of software to an enterprise and to a mission. This expansive vision of software value must take into account the essential role of systems engineering and its tight coupling with software engineering. In the large, the value of the CMMI lies in its role as an enabler of strategic software management. Strategic software management revolves around knowing what the customer needs most, aligning the best capability to provide it, understanding current practice, measuring its critical aspects, selecting the most promising changes, planning for lasting improvement, raising the ability to improve, and staying the course. In framing the issue around strategic intent, means, and measured outcomes, the value of the CMMI can be leveraged in terms of strategic software management, and the statements of strategic intent can be cast directly in the context of the business, management, process, engineering, and operations cultural drivers of the organization and its industry sector. The adoption and expert use of the CMMI leverage the means through an organizational culture, professional environment, and process framework. The way of thinking put forth by Ivers Jacobson in the Software Engineering Methods and Technology, SEMAT, and the Essence Kernel provides the means to unlock the hidden value of the CMMI in the large. The Software Engineering Method and Theory, SEMAT, formulation and its kernel are the essence and common ground of software engineering. This common ground of 7 dimensions, termed alphas, and the sequential states of progression associated with each alpha, is that basis. The alphas and the alpha states are intended to be independent of particular methods, practices, and tools, and so possess the capability to guide progress and assess status of any software project, regardless of method and practice selections. The result is manager-friendly and understandable. The customer space is framed by a stakeholder shared vision for a well-conceived value proposition for the opportunity with convincing and consequential outcomes. The solution is bounded by stakeholder agreed-to requirements and user stories, and a software system architecture that facilitates a usable and operational software product. The endeavor's work is performed by a well-selected and ready team and a way of working based on established principles and foundations. The alpha state checkpoints are the leading indicators that suggest consequential and satisfactory outcomes for these alpha states. A checkpoint on product work has been added to integrate with trustworthy software engineering expectations. For best results, think globally and act locally by adhering to the following expectations, which strike a better balance between practice-based method and overarching framework. Number one, stakeholders are in agreement and share a vision for the project. Number two, an opportunity value proposition has been established and there is stakeholder shared vision for achieving it. Number three, requirements or user stories are coherent and acceptable and there is stakeholder shared vision for them. Number four, the software system architecture is selected and comprises a domain-specific architecture to guide software system implementation, and the software system implementation is made ready and operational with no technical debt. Number five, the team operates in collaboration, shares a vision for the project, and is ready to perform with respect to shared vision, software engineering process, software project management, software product engineering, operations support, and domain-specific architecture, processes, methods, and tools. Number six, the way of working by the team has established foundations for software engineering process, software project management, software product engineering, and operations support. Number seven, the work is started only when all is prepared, including coherent requirements and acceptable user stories, stakeholders in agreement, and an established foundation for the way of working. Number eight, all work products are prepared and inspected in accordance with a defined standard of excellence, assuring completeness, correctness, and consistency. Since CMMI connects with middle managers who oversee the work, the challenge is to provide a better way of thinking in overseeing the work. SEMAT and its Essence Kernel and alpha states and their alpha checkpoints provide such an improved way of thinking with application to both the CMMI and Agile, as well as a wide range of methods in use in the industry. For openers, consider the alpha state checkpoints that follow here. Stakeholders of the CMMI can be found in the ranks of Carnegie Mellon University and its CMMI Institute, the lead assessor community, and the using industry sectors of telecommunications, financial services, manufacturing, transportation, medical, utilities and energy, e-commerce, and defense, and those enterprises seeking consequential outcomes in business management, process, engineering, and operations. Owing to such diversity, stakeholder agreement and satisfaction may be hard to come by. Stakeholders recognized, represented, involved, in agreement, satisfied with deployment, and satisfied in use. Opportunity value propositions vary in accordance with type of stakeholders and the forces that drive them, such as reputation, economics, mission, competitiveness, outsourcing, and high assurance. Consequently, each stakeholder comes with a unique opportunity value proposition without expectation of alignment. Opportunity: identified, software needed, value established, viable, addressed, and benefit accrued. User stories revolve around the strategic intent, means, and consequential outcomes of the diverse stakeholders, including the leading indicators of capability control, capacity control, change control, complexity control, defect-free, innovation, predictability control, quality control, release frequency, repeatability, resiliency, schedule control, span of responsibility, time to market, and traceability. Consequently, user stories may lack alignment in the configuration of consequential outcomes sought and found. Requirements: conceived, bounded, coherent, acceptable, addressed, fulfilled. The architecture of the CMMI is framed in terms of the 5 process maturity levels and the process areas that populate each level. It is at the process area that stakeholder and user story alignment can be expanded to include the provision for Agile and cybersecurity. Software system: architecture selected, demonstrable, usable, ready, operational, retired. The CMMI is the way of working for its adopters and spans management, process, and engineering. Software project management is based on the commitment management paradigm: planning, controlling, and measuring. Planning includes activities and products, tasks and responsibilities, and cost and schedule estimation and earned value management. Software product engineering is based on the lifecycle activities and the methods and tools used in each activity, whether waterfall, incremental, or iterative. Operations support is based on creating software products that produce the right answers on time every time, using processes that are dependable with respect to cost and schedule, and sustaining the software product and the processes used to create it. The maturity of the domain-specific architecture is determined by the breadth and depth of recorded experience on the models, methods, and paradigms used in the application domain. Way of working: principles established, foundations established, in use, in place, working well, retired. The team operates in collaboration, shares a vision for the project, and is ready to perform with respect to shared vision, software engineering process, software project management, software product engineering, operations support, and domain-specific architecture, processes, methods, and tools. Team: lead assessor selected, target organization, assessment team selected, assessment team formed, assessment team trained, assessment conducted, assessment report completed, adjourned. Work focuses on obtaining consequential outcomes associated with user stories and way of working beyond simple conformance, with process areas in anticipation of a CMMI future assessment. Work: initiated, prepared, started, under control, concluded, closed. Work products focus on perfection and expectations for completeness, correctness, and consistency. As shown here, the work product is identified as part of the way of working. The work product is produced, shared with the team, and inspected. The work product is complete, and its parts are traceable to predecessor work products. The work product is correct, and its parts are verified and provably correct. The work product is consistent in style and form of recording, and with the software system architecture and its rules of construction. The work product is value add, traceable to user stories, and the done criteria for the way of working. Harmonizing Agile use and CMMI adoption requires stepping away from the points of irreconcilable tension, viewing Agile as a method useful in establishing the foundations for the way of working on a project, viewing the CMMI as a framework useful in garnering senior management commitment to software engineering and management capability of an organization, and adopting the new way of thinking in SEMAT and its Essence Kernel for assessing the state of project progress and choosing next steps. In this way, what is done on a project can be decoupled from a predetermined pattern of sequence and dependency. Interpreting project progress through alpha state transitions, and similarly, selecting next steps is left up to the project team and informed only by the contribution to delivering on the opportunity value proposition. It is useful to think globally and act locally in adhering to the alpha state expectations. This is best illustrated in the resolution of the source of tension between Agile and CMMI associated with premature commitment to requirements in the context of a waterfall life cycle, all of which are thought to be built into the CMMI way of thinking. By viewing this issue and decision as a local action and a project choice determined by the way of working chosen by the project team, the project team can choose to initiate work without requirements, with some requirements, or with all requirements in place before work is initiated. Nevertheless, in whatever way the project team chooses to address requirements, the alpha states are useful in assessing the current state of completion and in setting expectation for next steps based upon the current state, which include the states of conceived, bounded, coherent, acceptable, addressed, and fulfilled. As a result, a trace of alpha state transitions on a project will reveal how close to the edge of chaos the project is, and even whether unconditional trust in the project team is warranted and wise. Here is my contact information. I would be happy to receive questions and have discussions with people on this important subject.